All right, so we are 3 minutes past the hour. Welcome to the August ECSS Symposium. So we've got two speakers today who are actually doing a pair of related talks. So don't worry about the time limits. They were discussing how one may go a little long or a little short. So think of these as being a paired set of talks. We have Anthony, and I'm sorry, Anthony, I should have gotten the pronunciation of your name before we got started.
No
from
worries.
The RDA Foundation, and Rob Quick from Indiana University. So I'm gonna stop sharing my screen. I will turn things over to Anthony. So go ahead.
Perfect. All right. So can everybody see my screen?
Yep.
Good deal. Okay, thank you everyone. Greetings to everyone, and thank you for providing your time and energy to hear about our work. My name is Anthony Juehne, so it's a tricky pronunciation, Juehne, and I'm the Adoption Manager and Senior Research Analyst for the Research Data Alliance US office. For a bit of background about the Research Data Alliance, the Research Data Alliance is a community-driven organization composed of over 10,000 members whose mission is to develop the social and technical data infrastructure needed to drive innovation surrounding data sharing and data interoperability. So in essence, how this operates is community members gather during plenaries twice a year. Our upcoming plenary is going to be hosted virtually in Costa Rica. And during these plenaries, participants discuss barriers to research data sharing crucial for addressing global challenges. Nearly 100 working groups and interest groups have been formed to craft social recommendations and technical solutions, which are then tested and adopted in the broader scientific community. For a bit of background about our community, the majority of our 10,000 members work in leading academic and research institutions, though some also hail from government and public administration, nonprofit NGOs, and commercial industry. For instance, 61 industry and commercial partners provide guidance and testing of our outputs within our organizational assembly. Our community of nearly 100 groups has produced 48 flagship outputs with over 75 published adoption cases, though much like the time here, we would always love and be interested in learning more about instances wherein our outputs have been used. There are a number of important activities ongoing within the RDA which can inform and support high-performance computing procedures and infrastructure. These range from practices to make data more discoverable and interoperable, software packages for linking multiple types of data throughout the research data lifecycle, to standards for metadata and PID management. I've included links to a few working groups and interest groups which may interest you all, though today I would like to provide a high-level overview of how multiple RDA outputs can be implemented to operationalize and fulfill organizational aims of open and fair research data and practices. Many of you are likely aware of the FAIR principles of findable, accessible, interoperable, and reusable. FAIR has been a crucial set of guiding principles to support research data sharing and provide, in essence, a goalpost for stakeholders and communities to rally around and aim for. However, achieving and measuring FAIR requires nuanced practices aligning multiple stakeholders across the scientific landscape. So, in essence, an additional framework may complement the principles of findability, accessibility, interoperability, and reusability. Some of you may also be aware of the Berkman Klein model. So emerging from discussions during the 2018 Data for Good Summit, the Berkman Klein Data Commons model synthesizes challenges and practices of constructing and managing data commons into 6 categories. These being humans, so issues surrounding how to build knowledge, inclusion, and education, institutions, laws, and policy for improving accessibility, privacy, and human rights, organizational practices driving collaboration and incentives, formats and labels. Here we're talking really about metadata, ontologies, and taxonomies and standardized vocabularies, to the data itself. So how is the data of good quality? How is it shared? How is it stewarded? And then the technical infrastructure wherein this data is housed and moved. So let's start by discussing how RDA really approaches this human elements of data. The main thing I would like you all to be able to take away from today is that curriculum and spaces, both online and physical, ought to be dedicated to promoting knowledge sharing within and across communities of practice, and RDA holds this near and dear to its core mission. Ideally, barriers to accessing education resources should be as limited as possible. So RDA, the RDA Co-Data Summer Schools program is expanding access to data skills, growing local expertise to tackle data-related challenges, and broadening the impact of RDA outputs to move towards global consensus and useful open data sharing. The strategic priority shared by Co-Data and the Research Data Alliance is to build capacity and to develop skills, training young researchers in the principles of research data science. Multiple additional RDA outputs align with strategies to educate and develop the existing and future data workforce, such as the cookbook for engaging researchers in data management, to guides for library science, and quick tips for finding research data sharing and research data. So let's move on to some institutional laws and policies. The role of international research ethics, law, and policy must expand to cover the methods, materials, risks, and responsibilities associated with the stewardship of research data across political and geographical boundaries. In lieu of definitive international research ethics and legal frameworks, examination and adjudication of differing ethical values and priorities across regions really requires asking the following. What are the laws aiming to prevent or protect? Are all parties' epistemic, cultural, and research values equally represented and protected in the definition of legal and ethical principles? What systems of accountability can ensure these values are represented and protected? So that's really the main vision and mission of RDA surrounding kind of the grouping of law and policy and legal protections. But I really would like to dive into some examples of outputs that demonstrate how this really comes to fruition. So the ability of a research communities to share, access, and reuse data, as well as to integrate data from diverse sources, requires effective technical, syntactic, semantic, and legal interoperability rules and practices. The Co-Data RDA Legal Interoperability Interest Group has studied the issues related to intellectual property of data and legal protections thoroughly. The resulting outcome is a set of high-level principles and practical implementation guidelines that can be used by all members of the research community engaged in activities that involve the access to and reuse of research data from diverse sources. Achieving consensus and enforcement of legal protections also requires the alignment of multiple research stakeholder groups. To demonstrate how the RDA platform and community allows for such collaboration in defining solutions, the RDA Data Policy Standardization and Implementation Interest Group convened a joint group of experts across publishers, policy experts, information infrastructure programmers and experts to define a common framework of data sharing best practices within scholarly articles. In essence, the group has defined a common framework for data publishing policy, allowing for different levels of commitment by independent journals and requirements as well as disciplinary differences across these journals that could be agreed upon by multiple stakeholders. Here in this slide, you'll see in essence, those requirements at a high level. So one major impact of the RDA is the capability to convene stakeholders across the scientific landscape to really begin defining and inform the systems of accountability for legal protections. Resulting systems for accountability can include and feed into technologies for documenting and exposing legal protections and licensing to approaches for educating communities on their data rights and responsibilities. So we've talked about some of these legal policies, but how does this actually feed into organizational practices? Incentives for collaborating in research data stewardship and sharing ought to be clear, operative, and shared equally among all project members. Expansions of research networks to a wider community of input and impact through organizational partnerships and reliable stewardship of research products provides a powerful incentive for members collaborating within and across teams. Reliable stewardship of data within and across sites thus depends heavily on the capacity to implement clear data management and stewardship workflows. core to RDA's mission and vision, which when possible ought to be made both machine and human readable. One output that demonstrates this.
Like, Anthony,
Yes.
can we just go back a couple of slides? We got a question,
Yeah.
one where you had all of these circles.
Yes.
Okay, yeah, this one here. It looks like something got cut off. So this question from Mona, what do the columns mean in that table? Is there a heading?
Yes, that is here on the left-hand side, not required, may be required, required and enforced.
No, sorry, not the meaning of the symbols, but the meaning of the columns.
Yes.
So what we're seeing is the top row that we're seeing for the table is data citation.
Yes.
And then of course there's a bunch of solid circles.
Oh,
but is there a row above that we're missing?
Yes, apologies. These are in essence the requirements of that policy framework. So meaning data citation ought to be documented within the data that is to be published, as well as data licensing, researcher, author support, etc. So those are the high level descriptions of the requirements of the policy framework. And I would also highly suggest members and participants to maybe follow that DOI in the link there to the most recent paper that was published by this interest group that expands upon each of those requirements in a bit more detail to flesh out how they can be implemented within the peer review and publication process, as well as just a bit more depth about each of those requirements.
Okay, partly. So if you could post that DOI into the chat when you're all done with your presentation. Of course, these slides will be presented later. Posted later. But still, it's still not clear. For example, when I look at that first row, I see data citation, and then I'll see a series of 6 solid circles.
Yes.
It's not clear. Like, what is the first one? What is the second one? What is the third one?
So each of those represent independent and individual journals that are implementing. Okay. Yes. So thank you. I didn't understand the question well. So yes. So that first left column is in essence the criteria, and then each of those are how individual journals are implementing those requirements within their own practices.
Okay, great. Thank you. That definitely clarifies that. Thanks.
Okay. Yes, sorry about that. And I'll make sure to share information about that group as well as the publication, so that we can keep moving. Let me take a look if there are any other questions.
Oh, that was it.
Okay, thank you. Yeah, and thank you for that question and point of clarification. That's very helpful. Okay, so we've talked about some policies and organizational practices surrounding data sharing and data stewardship and management. So one output that's extremely helpful in data stewardship across organizations and within organizations is the DMP Common Data Standards. So data management plans within and across organizations are often static, written in a doc or PDF format and non-machine readable, and lacking standard section headers and metadata describing each process and protocol within data management. The DMP Common Standard provides a reusable way of representing and exchanging machine actionable information on themes covered by DMPs, independent of any internal data schema or model used within an organization's research data environment. The left-hand figure here demonstrates how this process operates across different stakeholders within the research environment. The right-hand side figure demonstrates some of the content and pieces of the schema within the common standards. In essence, the solution, the DMP Common Standards make data management plans able to evolve across time in a machine readable way where each stakeholder can edit and evolve the data management plan in real time, aid in discoverability and transparency of the data management plans across teams, make sure everyone on the team can access, contribute to, and understand the plan, and make the active data management plan interoperable with existing tools, including electronic notebooks and data management plan templates and the like. Multiple recommendations have been developed within the RDA to support the capability of stakeholders across the research landscape to make informed decisions regarding how their data is managed and shared within and across organizations. These range from software code that we discussed for exposable data management plans to workflows for sharing and publishing data across organizations to quick start guides for early career professionals, librarians, and research admins. So now comes the fun part where we're really considering formats and labels. And when we're discussing formats and labels, we're really talking about how data is described and documented in metadata, ontologies, and standardized vocabularies. We ought to limit social and political barriers to participating in developing, testing, and implementing such a standard. So that's really where that community piece comes involved, where multiple people around the globe can participate in developing domain agnostic and domain specific standards. However, it's often difficult for researchers to know where to begin when considering what metadata standard may be applicable and appropriate for their data, as well as how to effectively implement said standard across their workflow. The RDA Metadata Standards Directory provides a helpful tool for the following. Researchers can learn how the various metadata standards applicable to their research. They can discover controlled vocabularies used by research communities and understand the elements that comprise those standards and vocabularies, and then map between elements when combining data from different sources. So we've addressed a tool that's helpful for defining and discovering appropriate metadata standards for particular data workflows or data types, but we haven't really delved into data formats much. Without knowing the format of the data one is receiving, it's difficult to know how to analyze, store, or in other ways fit the received data within a data-centric high-performance workflow. The data type registries output built a federated registry of defined data types to support automatically identifying a data's type and the associated sources and platforms which generate the defined types. This could be integrated across multiple different platforms and to provide both humans and machines to more adequately and effectively and speedily define a particular data's type within that research and analysis workflow. Multiple interest groups and working groups within RDA have been highly impactful to defining standards for documenting and describing data across the agricultural sciences, and particularly including metadata formats for enhancing the interoperability of wheat and rice data globally, as well as initiatives for aligning stakeholders across the agricultural community, such as INRA, to better enhance data interoperability, transparency, and quality. Metadata and ontologies are essentially the bread and butter of RDA, with multiple groups addressing how to better document, describe, link, and categorize data within and across domains. I would love to take more time to discuss some of these groups, and if anybody has questions, I'm happy to address them, but for the sake of time, we'll move on, but please don't hesitate. So let's move on now to that data element within the Berkman Klein model. Data, of course, is at the core of everything we're discussing today. But for the sake of time, I would really like to focus on the aspects of data sharing and data reusability. The focus surrounding data sharing should be on 3 priority areas: access and benefit sharing, accountability and transparency, and quality and safety. Capacities to implement policies governing checks upon the fairness of particular research workflows differ across regions and institutions, and thus should be as aligned as possible. Agreement to share the data and the associated legal requirements ought to be defined with group consensus at the very beginning of the project, so that participation for stewarding the data can commence as the project is being proposed and initiated. At the infrastructure level, the scalable dynamic data citation principles can provide clear guidance for how to enhance the transparency and reproducibility of data collected and shared from a large evolving data store. In principle, when researcher 1 queries a large evolving data store, such as a health data repository in a hospital, a persistent identifier and a subset of metadata is generated both for the query and the query data set. Thus, both the original researcher and, say, researcher 2, examining a data set shared with them, are able to successfully reproduce a previous data set as it existed at a specific point in time, only using the persistent identifier as provided in a data citation. So they could either generate the original query, or they could re-execute that query, make additions to the subset and data itself, and generate a new version of that data using just the persistent identifier either for that data set or the query itself. Obviously, data and digital objects are at the core of every aspect of RDA's work. Multiple groups address the capability to assess the quality, reusability, and fairness of research data and data workflows. Please, any questions, we can talk in more detail as well, including the new release fair data maturity model, to work that's ongoing in COVID, to a number of different initiatives. So finally, I'll touch base on some technical infrastructure.
Anthony, actually,
yes.
do you have time for a question? We have from Amit Charazia. Yes, yeah. Could you share any data platforms that are open and ready for others to reuse, which incorporate outputs from RDA?
Yes. When you mean data platforms, do you actually mean like a repository, or maybe to expound a bit on data platforms? I'm happy to share some existing adoption stories which may elucidate how those platforms, including data repositories, existing kind of third-party explorers of data are available. So I can link those in as well. Software, okay. Yes, I'm happy to share those. So for instance, I can share examples of how health repositories have implemented these, to agricultural data repositories, as well as geophysical and astronomy data repositories. So I can share examples with those, and they're public, and you can access and read more about them as well. And lots of really great lessons learned within there. And to Rob's point, yes, thank you, Rob. Rob's presentation will provide some real great concrete evidence of that as well. There are okay, I think, so to the implementations question, there are existing kind of packages of software and some documentation around that exist in some of the working groups and interest groups repositories, where you can reuse some code to help you get up to speed to implement some of that, some of the outputs within your own infrastructure. So there's reusable code and some reusable documentation that could aid in getting these outputs implemented within your own work as well, and as well as the community that can provide some guidance and feedback, as well as multiple publications that share lessons learned and processes and methods there as well. So I would highly suggest maybe going into each of the working groups repositories themselves, and then I can also, if we can go and discuss offline, I'm happy to share GitHub links and other repository links as well. So I want to make sure we will have time for Rob as well. So I'm going to go through some pieces about technical infrastructure and some additional RDA outputs, and then maybe address some questions there as well. So clear roles, responsibilities, and resources, both human and technical, ought to be defined for deploying and managing technical infrastructure at the start of a project, and dedicated to oversee project technology within a central node or distributed across multiple sites. Multiple RDA outputs can be useful in enhancing the interoperability and sustainability of such technical infrastructure, both within and across sites. One that I think would be particularly interesting and interesting to you all is the PID kernel information output. So you'll hear a bit more about this as well. So existing middleware is broadly insufficient for linking multiple persistent identifier types, consistently growing in volume and complexity across multiple different science fields. The PID kernel information working group defined a schema to inject a tiny amount of metadata carefully selected into a persistent identifier record. So this left-hand columns you'll see here are short descriptions of those metadata. The deployment of enhanced persistent identifier metadata can promote the development of an entire ecosystem of third-party services that can process the billions of expected PIDs and do so with more information at hand about an object, with the added benefit of reducing the costs of tracking persistent identifier links and data provenance issues. In addition, we have loads of researchers collecting, using, interpreting, generating, and reusing digital objects across multiple fields. Collections and streams of these digital objects are growing at an incredibly rapid pace, and we need to get clear on what these objects are, how we need to be documenting and storing them, and how they should all link and talk to one another before we get overtaken by this large sea of data. The Data Foundation Terminology Working Group has generated a common core data model for organizing digital objects to ensure accessibility and reusability across data infrastructures. So this is essentially at the very ground level of describing data objects and digital objects, what ought to be the common core data model across multiple different repositories at base. But such digital objects are now spread across more repositories with even more data, yet are often siloed and non-interoperable. In addition to this common data model, as well as strategies for PID management, how else can data be linked and tracked? So there's a working group within RDA that's been really exploring other strategies for linking and tracking data. The Data Description Registry Interoperability Interest Group provides an interoperability model for cross-platform discovery by connecting data sets together on the basis of co-authorship or other collaboration models such as joint funding and grants. So here you can see how multiple different data types based upon those co-authorships or grants can be linked within that RDA switchboard and create a more robust view of how authors and data objects and research outputs are all connected together. So I want to make sure we have some time for Rob as well, because I think you'll hear in SEAGrid and eRapid how multiple RDA outputs can be very useful for interoperability, reliability, and sustainability of research data infrastructure. We'd love to hear your thoughts and questions. How about how our organization can support your needs? And I'll be sure to drop those pieces of information into the chat so that throughout any other questions, you can access those. So I think for now, I'll go ahead and stop sharing and pass it off.
Great, thank you, Anthony. And while Rob is getting set up, any quick questions for Anthony? All right, Rob, whenever you're ready, take it away.
Okay, let me share my screen. And Anthony talked a lot about PIDs, and people have probably been hearing more and more about persistent identifiers or DOIs or data citations with persistent identifiers. Just as I'm setting up here, just to know, the EOSC, the European Open Science Cloud, you can probably see the document on my screen, is right now writing their PID policy that will be released to everyone participating in the European Open Science Cloud. I'm part of the architecture working group, but PIDs are here, they're here to stay. You're going to see more of them. You're going to see them at a more granular level. They've been here, they've been around for years and years as identifiers to publications, but I think we're seeing an explosion in them, which is why much of the work in RDA that Anthony was citing is looking at how to interact with PIDs and how to make data interoperable. It really is linked there, and I'll go into some of that as I start my presentation here. But just so everyone's aware, Europe is getting ready to release this persistent identifier policy that will be enforced through the entirety of the European Open Science Cloud. So let me see if I can view and presenter view here. So I'm going to talk real quickly about a project that was funded by RDA US. So this was out of Rensselaer Polytechnic and Fran Berman's group there. Funded us to do a adoption project, and it was a small adoption project, relatively small money, relatively short period of time. But what we were going to do is take some of the RDA outputs and recommendations that had been discussed for several RDA plenaries going back several years, and really see what happens if we put them into a gateway environment. So I've titled this Towards Fair Data Workflows with SEAGrid and Rapid, but the question is, how can PIDs be used to define workflows and pieces of workflows and metadata associated with workflows that were executed through a science gateway environment? So we took SEAGrid, and I do, before I get started, want to thank Sudhakar, you, and Juehne, who did a lot of the work in this project. Again, it was very short amount of time, very a small amount of effort, but I think we accomplished something that is a model that will be expanded on as we move into the future. So, so just a scenario as to why a science gateway researcher would need to worry about things like PIDs or about things. So everybody at this point has heard FAIR over and over again. I don't know, people understand FAIR and the acronym and what the 4 words mean. I don't know how many people actually have delved into the details of that. We'll look at that in a little bit, but researchers are more and more concerned that their digital objects are, that both they use for their research and that they produce during their research are governed by the FAIR principles. And we also want to be sure that the gateway work is reproducible outside of the Science Gateway environment. What happens if you publish a paper based on a Science Gateway and a researcher who may not be able to have access to a gateway wants to reproduce that work? Without having that gateway environment, it's very difficult to even consider reproducing it at the current time. However, if we publish some metadata about the workflow, it goes a long way towards the reproducibility, at least of the computational portion of the experiment or the research. And they may want to share the steps and not just the data. With PIDs, data sharing is something a lot of people are working on, but then you have workflow steps, and you may want to share that along with the actual results or the output data that you would put a PID on in something like DataCite. And then there's also the advantage of, if you have your workflow defined by persistent identifiers, which again are external to the gateway, you can potentially tweak that by adding either new inputs, new outputs, new versions of software with the simple, and this is, we're a little ways from this, but by simply replacing the PID for a newer version of the software, you could reproduce the workflow with a kind of modular approach that the software would be replaced without the other steps surrounding it. So I do want to say here, if I have time, I'm going to do a quick demo of this because I think it's pretty interesting to show how quickly PIDs can be issued and what they relate to as far as in middle of workflow. But I do want to go back to the FAIR principles. And this slide was provided by Luis Benino out of Leiden University. In Leiden University, he works directly with Baron Mons, who is the primary author on the paper that defined FAIR, but he split here the FAIR principles into what are the technically implementable FAIR principles and what are more of the community implemented or societal things. So in green, you can see things that are technically implementable, and then the black lines are things that are they may be blue. The black or blue lines are things that are really take some societal buy-in to make happen. So as you can see, technically you can assign a globally unique identifier. Making that persistent takes somebody who's willing to house the services that are persistent, that allow that. Data can be described with metadata. That's technically implementable. Rich is something that would be defined by the community as to what exactly rich means, and so on. The one here in accessible, the one that's interesting is that you have an open and protocol that is free and universally implementable. We're using a open protocol here. So the adoption project that we did was basically how much of the green things here that are technically implementable within FAIR can we put into a relatively quick adoption project. So I want to take one step back before we get into how this was done and talk about SEAGrid and what SEAGrid is. It's the Science and Engineering Application Grid. The PI is Sudhakar, who I think everybody in the community is pretty familiar with at this point. But it's a science gateway built on the Apache Area Vada middleware framework. And really this adoption, while it was done in SEAGrid, it centered on some small molecules that were and their fluorescent properties. These were, so we had a small enough use case that we could do a implementation relatively quickly, as I said. So the other part of this is the rapid SEAGrid, and about a year ago, I think last spring, I did a long symposium on the rapid Testbed. If anyone would like to go back and look at that, there's about an hour-long presentation on all the details of that. It is still available. I looked at it the other day to see if it was still there in the backlog of these symposiums, and it's a pretty good way to get all the details of what the rapid Testbed is. But basically, it takes some simple services. One is a handle service, which does the minting and resolution of persistent identifiers. So it assigns persistent identifier and allows you to get some state data back upon resolution. A data type registry, which Anthony talked about earlier, which is an RDA output, and then a protocol for operations on digital objects. And that protocol is called the Digital Object Interface Protocol, and it's part of the handle service and a service called Cordra, which also the DTR is built on. But it's a protocol that defines some operations on digital objects that can be easily implemented and reusable. And again, it's open and universally available. So these are the basic cyber infrastructure components that allow for the green portion of the FAIR principles that I mentioned before. As I said, the portions in black are more for the community to implement and not necessarily technically implementable. And it leveraged several RDA outputs and recommendations, including the PID kernel information, a strawman profile which Anthony showed, the data type registry, and all this really came together in a data fabrics working group within RDA, where we started talking about, okay, now RDA has had several outputs. What happens when we try to string these together and make them into a service? And that was the rapid Testbed. Now this is NSF funded in the eager grant. The grant numbers here, if anybody would like to review that. And I've also put the project documentation site in here for anyone who wants to look at that more in depth. So what we were doing again was taking the raw data or the input data, assigning it PIDs. If it were to go through some data preparations, that would also be assigned to PIDs, so that software scripts that might do some preparation steps on the data. And then it would also put PIDs on intermediate data projects. There would be some number of iterations where it goes through some preparation for the final analysis, and that final analysis would also get a PID. So you can see from the line on the bottom that you assign PIDs at every step of the process. We did this with this relatively simple workflow, with the understanding that there are much more complex workflows, and there's probably some future integration with something like the common workflow language that we may need to do to describe more complex workflows. But again, in the short prototyping time, we did a relatively simple workflow. So
Rob,
yes.
quick question here
Sure.
from Mitch Razia. Is data versioned in SEAGrid? If so, how and how are PIDs assigned to them? And if not, where to look for examples and implementation?
Okay. So data can be versioned in SEAGrid, and it can be versioned within the state information in the PID. So one of the fields within the PID kernel information profile is the version. And you can also do things like, this is a copy of this data, or this is a offshoot or some rearrangement of this data. So the fields exist within the state data to point it at previous versions of the data. And in fact, there is a version field, so you can version the data within the Rapid system. Now, the data is not versioned within the SEAGrid implementation that we've done outside of, you could do it within the Rapid. The mechanisms are there to do versioning of data. It's not really done in the SEAGrid implementation.
And Rob, sorry, we have another question from Ramazan Ivan. Is it possible to track data to see the steps involved in generating data by using PIDs?
So yes, and in fact, we'll look at that moving here shortly. So yes, you are able to track these in the relationships between the data and its offshoot and the processes that it goes through. So, okay, anything else while I've stopped here? So, okay, then I'll proceed. So we've expressed it here as a tree of what happens when you actually execute a workflow. That workflow is given a PID, which is an overarching PID that has 3 children: the stuff that is considered input, the stuff that is software, and the stuff that is considered output. The input has the various different information that is part of that is put together in an input file. That includes there's some routing information, some linking information, along with the actual, in this case, they're small molecules, so there's coordinates and charges on each of the individual atoms within the molecule. The software PID probably needs to be broken up into 2 things, we realized, but we didn't have time or effort to do that. The software PID really should be the name of the software, the description, and the version number. It ended up getting all of the environment information, also number of threads, other things like number of processors used. So we lumped some stuff into software PID that probably should go into an environment PID in this case. And then the output PID points PIDs at the logs and the standard output and the standard error in this case. So I'm going to do let's see, I have about 15 minutes. I'm going to exit out of here and do a quick demo to show you how this would work in real life. So let's go view full screen. So everybody should see now the entrance on the SEAGrid portal. This is just at rapid.seagrid.org. I encourage everybody to explore if they'd like and create accounts and such. Here's one of the issues with doing a live demo. We made an adjustment to change the banner, and I had a saved ID here. Whoops. Now everybody's seen what my potential password is for. So, Sudhakar, are you on? Is this something that maybe I shouldn't have tried to do a live demo? we had an old banner up and we put a new banner up, and maybe I just pressed the wrong button. That could be it. Again, live demos. Okay, I pressed create instead of start. So we're going to do a Gaussian 16 workflow here. I do need to exit full screen mode. So this is basically a Gaussian workflow where you bring your input files, you select your compute resources, and execute them on a standard in a standard workflow through Aryavata. So let me, I need to exit full screen mode, and I have a neopentane diol molecule example here. So I'll upload my input file. Again, you can put multiple files there, but in this case, we'll just use one. And then I would save and launch. And the great thing is, as soon as you hit save and launch, you get a PID that points at handle.net, which is external to the gateway itself, and you can go and get some immediate information about it. Now, this is just the overarching PID. It'll be populated after the run is completed, but you can see here, we went to handle.net. That pointed us to to the Rapid server, actually, which is the handle service that this PID is being registered on. But you get some immediate information, and you can see that that's external to the gateway. Now, I'm going to do the cooking show thing and go back here to my dashboard and look at a run that I did earlier today that completed, so we can look at what that metadata that is being captured is. So you can see here, this is a run that I did earlier, same run that I was just looking at, that has completed earlier this morning. And we're going to go to handle.net, get information about this. And this gives us we have now the three sub-identifiers: the input data, the output data, and the data about the software. I'm going to go ahead and grab the input data here and put it up into the search. And this will take me to some of the information that we used in the input. So there's the linking data, the route data, the comment, and the actual data, which is then two things: the charges on the individual atoms and the coordinates of the atoms. If you look down here, you can actually see the full input file is here in the usage. So potentially externally from the gateway, you could recreate this. Now, the software tag has all the versioning, has the again, some environmental information, but in the interest of time, I will move forward. But this shows you that you immediately get these globally unique identifiers that can be resolved external to the gateway, that give you the metadata regarding the workflow that was executed. So I'll go back here real quick. And if you want to explore, there's a handle that I put in here from an earlier run, and you can go there. So just in conclusion, we have integrated SEAGrid with the Rapid Testbed, and now the workflow components of SEAGrid upon execution will get PIDs that are, again, globally unique and external to the gateway. So someone who receives a research paper down the way who wants to try to recreate or reproduce what's going on can do that without having to get access to the gateway. Many gateways are open, but there are some that are not. Yeah, so you can see where it may be necessary, and gateways have a lifetime also. While they may be maintained to a certain point, some of them will go out of production after some amount of time, and you don't want the results of the experiment to become obsolete when the gateway becomes obsolete. Let's see. So they describe the various different computational processes. You can You could potentially recreate the entire computational workflow externally if necessary, again, by PIDs at the pointing at the input data, the software and the versioning, and even intermediate data products along the way. And so you would not need access to SEAGrid to get the metadata necessary to recreate the workflow. So this directly impacts both the findable, accessible, and interoperable principles. A little less the reusable principle. If you look back at my slide, you will see that reusable is all in black because that really talks about some community standards and things that are not easily technically implementable. This again, would be expendable to metadata, but also we've now published the client, or we're getting ready to publish the client that would allow this to be used within any service or any gateway to call out to the rapid services to get these PIDs and to assign PIDs to the various products within a gateway. And I won't say that again because I've said it many times. So future work, there's still a lot of work to do. This was a prototype, again, done in a quick, though thoughtful way through some joint RDA and rapid effort. We still need to document that client, and the client is the piece of software that lives on the, in this case, on SEAGrid, but would live on the gateway, or it doesn't even necessarily have to be a gateway that calls out, does the minting of PIDs, so gets PIDs for the data products, and then at the same time stores some basic metadata and allows the resolution of those PIDs to what that metadata means. We do need to handle more complex workflow. The workflow that I showed you was input run through a single piece of software and the output. Everyone knows that workflows are much more complicated than that, but that is the very basic workflow. And we would need to do some relationships between various different data and intermediate data and the software processes that they were using. Of course, we don't want everybody to have to do what I showed you there in that demo of copying and pasting PIDs into search engines. So there needs to be something that allows the workflows to be more readable by humans, and some sort of visualization that allows people to see how the workflow went. Again, copying and pasting PIDs into a search engine is not the right way to do that, but it is the early way to do that. We are looking at populating some public repositories with these PIDs after they're issued. In the case of the SEAGrid and the project we did on the fluorescent properties, the place to publish these would be fluoroforbes.org. There's another open inventory service that we potentially could publish to, and that would allow these PIDs to then become part of another repository, and those repositories to access the metadata about workflows or about data outputs. Of course, I think that I worded this poorly, but find a way that other gateways could use this, and what this really offers in value to the end researcher. And then right now, Rapid is a test bed, so it provides persistent IDs, but it's not a persistent service. So Rapid would have to be operationalized as we move forward to doing this in a non-prototype environment. It's very robust services. However, some performance analysis, again, we do very simple workflows. What happens if you have, hundreds of thousands of input files and, hundreds of thousands of processes or more in some cases that are kicked off? Can the rapid services, or can the handle services and data type registry services keep up with load from a large scale workflow? This is all work that needs to be done. And I think that's it. I left 3 minutes for questions. That's not very much, but I can stay for a little while if people do have questions.
Great. Thank you, Rob. Excellent presentation. Thank you also, Anthony. We have a question up first from Amit. So Amit, why don't you just go ahead and unmute and ask your questions, because I see that might be multiple parts to it.
Yeah, sure, Bob. Thanks for the presentation, both Anthony and Rob. I think this is work in an interesting direction where the scientific community is heading, and which lacks a lot of software implementation behind the ideas being put forth. So my question is, you ended up choosing the Handle service for minting the PIDs.
Mm-hmm.
What was the motivation to kind of pick Handle? Are there any others that are there? And you also referred to kind of, rate limiting. Are there any rate limits to mint PIDs, right? Because that could overwhelm the system.
So there are technological implementations. There are not so much. So once you have a prefix that the Center for National Research Initiatives issues for a reasonable fee, it would be about $50 a year. The number of PIDs that you're allowed to register is not limited by, it is limited by your hardware, not limited by your, not limited potentially by how many PIDs you can do. You could mint millions of PIDs, cost the same as minting 3 PIDs. Now, the performance is something that we really have to do a good look at. It's been done internally by CNRI, and they say that you can mint about 1,600 PIDs per second on a reasonable size machine without a problem, which means that's going to be as much as anything I can think of can do currently. That 1,600 a second allows you to do billions per. Oh, I would have to redo the math, but they say it's pretty robust. However, I want to look at this. There's also a counter argument coming out of Germany that they weren't able to do more than 10 to 12 based on referencing the DTR per second without it having some slowdown issues. So that's a wide range from between 10 and 1,600 per second. I think it's probably somewhere in between, but that work needs to be done to see really how it's done. Now, I see these as federated service, so it wouldn't be a single handle service or a single minting service that would do it, all PIDs for research in a country or a region or whatever it may be. These are lightweight enough and cost efficient enough that you wouldn't need to, each laboratory could do one without too much of a cost issue, or at least each university might offer it as a service. Now, other services, there are other technologies that do this. We have been somewhat aligned with CNRI, and in fact, one of the co-PIs on the RAPID project is from CNRI, and we've gotten some effort from them. The handle service is of course what's behind the DOI services. So under the covers of DOI is a handle service, and it seems to be the most mature system that at least I've seen that is in use in most places. They also have the DONA Foundation behind them that are backing up the global registry. So we're assured that the global registry will be around in tens of years, whereas there's a little less commitment from other places, mostly because a lot of this is relatively new and being thought about. So a few reasons that we went with handle services. One, we have the DONA Foundation, which is a non-governmental organization that has committed to making these persistent. So even after RAPID goes away, you should be able to resolve those, resolve the PIDs that we have and get some metadata back about them. Yeah, so those are the reasons. There are other services, and I think there are some other services that are worth looking closely into. URNs are used in some communities, especially text-based communities. There's a few other technologies that escape me, but yes, research that should be done.
Thank you, Rob.
Okay, and we also had some questions earlier from Mona, but I see that you've been having a chat with Anthony. So did that answer everything that you wanted to ask?
Yeah, I think so. Thank you very much. I did have one new question. I was wondering the fields that are retrievable, is that customizable per project or whatever, or is it, how do the fields get defined?
So you can define the fields in the handle service. They're just key value pairs, and you can make them whatever you like. The RDA PID kernel information profile is one suggested profile, but it's not necessarily the only profile. And in fact, the technology allows you to both define and put a value in any field that you like. The data type registry then of course tells it what type to expect from that field. So if you're putting in something, say a creation date, you would want to define that in the data type registry as a ISO formatted date the data type registry allows you to have that be machine actionable because you can then define the format of the data.
Okay, thank you very much.
Yeah. And in fact, the one thing that people agree should always be in the PID kernel information is the location of the data, right? So some pointer at where the data can be picked up, because the PID itself does not house the data. The PID is only metadata about the data. So the one thing that really needs to be in the PID is the location of that data if you were to want to get it or use it in some way.
Great, thank you. So we're about 5 minutes past the hour. We should wrap up unless there are any more pressing questions. All right. So again, thank you. Thank you to our two speakers, and Anthony Juehne and Rob Quick, for the great presentation. See you next month for the ECSS Symposium, and these slide decks and videos should be up online pretty soon. Thank you very much, everyone.
Thank you.
Thanks, everybody. Bye.